Hi there, I'm going to show you this little trick that I sort of learned about how to create a image on your board, on your PCB board. So for instance, this one here is the one we're going to be working with. And instead of the image being on the solder or silkscreen layer, it's going to be on the pins and pads layer. So that way it will come up hopefully silver and shiny and all that, or gold and shiny. Anyway, so how I did this was I created a simple processing sketch, and it basically goes through the image and creates little solder pads for each black pixel that it finds. So there's a really cool document online, and it's basically called, what is it called? Footprint Creation for the Open Source Layout Program, quote, PCB, quote. Okay, I'm not sure why the quotes are there, but anyway, it's a really good file to use, so that way you can see, like, this is how Element works, and these are all the variables in Element. If you ever like open up your footprint file in a text editor, you'll be able to see all this stuff. And yeah, you know, this is, so this one is actually an example of a TO18 transistor footprint. So if you can read that and visualize it, it's pretty cool. And then, so this is the one we're mainly focused on here. It's pad, and it gives us all these variables so that we can use them. So jumping back to the code now, we load up the image, and we're going to write to a file called processing.footprint, and we're going through all of these pixels, and if it's not a white pixel, then we're gonna say, yeah, put a solder pad here. And basically the solder pad, since it has to be a line segment, it's just a very small line segment, as you can probably guess by the x and y coordinates here. But what makes it thicker and thinner, or gives it basically a width to it, is this thickness variable right here. And so up here, we're going to say it's going to be 200. That's 200 mils for unit's sake. And then there's also a clearance, and we'll go more into that later. And then, yeah, then it saves it, and then it's done. So yay, let's go ahead and run this. Run. And then there's no GUI, it just prints out some x and y coordinates to the console, but in here is our file. So let's go ahead and open it. So yeah, so this is pretty cool, right? It's the picture of the robo-bird in sort of, yeah, in the pins and pads layer, except that, so let's go ahead and draw like a fill here for the top layer. As you can, as you can see, that might not have been exactly what we expected, right? Because the clearance, the clearance for the pixels, or the pads, the pixel pads, is it's a little big. So what we can do is go back here and scroll up all the way to the top, yay! And then we'll change this clearance to just basically a number that I've found that works really good is t upon 4, t being the thickness of these pixels that we're creating. And so that now saved, and now gEDA always gives us this really nice thing here, so we can reload that. And then now let's zoom out, and here's the new fill. And as you can see, this is much better. Let's see if we can make that there. So something that we'd expect. You can, I was debating whether there should be or shouldn't be some sort of clearance, but to play it on the safe side, there probably should be some clearance. So this clearance is quite minimal. So you can see I'm having issues zooming in and out of it because it's so minimal. So if each of these squares is 200 mils, then obviously the clearance is quite smaller. But of course we want to put this into our actual PCB, so we're going to copy this one and paste it over here. Yeah. And then now we can go and file load layout data to paste buffer, open this footprint. Now we can put it here, and voila, there it is. And so this is pretty cool because when you say you want to switch to the other side, so shift and tab, and yeah, so you can see it's only on one side, but you know, you can change it to whatever side you want. I was figuring for the artwork it's probably better that you're gonna want it only on one side. But of course you can look up in that document on how to put it both sides. And so there you go. So if we zoom out, you probably won't be able to tell about the pixels. It'd be interesting to see if you could actually, really see the pixels in real with the solder and stuff. But anyway, so that's just a little trick that you can use, and it should hopefully be pretty cool. I haven't tried it on any real boards myself yet, but I definitely want to. So if you try it, let me know how it works or if it doesn't work. And I'm sorry if it doesn't work if you watch this tutorial. Alright, well, there will be more later, and you can catch the processing code and everything in the links below. Alright, see ya everyone.